What's up, everybody? It's Coach Sharf. Most of you have not had me before, so you haven't seen any of these. So welcome to my video channel on YouTube. So like I said, if you y'all had me in Algebra 1, I did the practice problems when we were still thinking we were going to do the EOC, and then it turned into extra credit. Some of y'all had me last year. Again, most of y'all are seeing this for the first time though. So as I've said in class, pretty much all my notes, some PowerPoints where it's just PowerPoint might be exception. If I, show you some videos from Khan Academy, I'll post those links. But for the most part, I'm going to post myself going over the notes from the active board slides. All right. So we're starting with our first notes on imaginary numbers. So let's get into it. Let me actually hit share screen instead of just clicking on it. That would help. All right. So unit 1, quadratics revisit. Okay, so, if you didn't get these in class, I kind of put this up as a title slide. So what do I mean by that? Well, if you're just starting in your brand new notebook for math, or if you got a big 3-ring binder in your math section, just trying to kind of help y'all take notes for the future. I'll do one big title page like this. Okay, one big title page like that. Make that your whole first page. It's optional. You don't have to do that, but if you're flipping through, again, if it's the start of a brand new notebook, hopefully it should be obvious that you're starting with the first unit. But, maybe if you got to burn through a couple notebooks this year, just to be safe. If you don't want to make the title slide, that's fine. What you can do is go ahead and start with imaginary and complex numbers. And really, we're just focusing on imaginary numbers in this video. And the next video, we'll do some complex number stuff as well. But you can put that as your header on the top of your page, and then we can go. So as I said, I'm going to try to go through these a little quicker. Y'all can stop and pause the video to copy down pages as you need to. But I'm going to try to keep it moving so my videos aren't 45 minutes long or an hour long or anything like that. All right, so first thing we're going to do, revisit the set of all real numbers. Again, this is something y'all seen multiple times before. Maybe not recalling it immediately because you don't really talk about this kind of stuff in geometry, but we have our natural numbers, which are our counting numbers, 1, 2, 3, 4, 5, 6, so on, so on, so on. Whole numbers, that's a subset of whole numbers, but all you do for whole numbers is add the number 0. I said in class to most of the classes, not that I'm a professional mathematician, I don't know why 0 counts as a whole number. I don't know why 0 counts as anything because it represents nothing. It should kind of be its own thing, but whatever. Whole numbers are a subset of integers. So with the integers, we now bring the negative numbers into play. So y'all can see I have the ellipses now for going both ways, because you can go back this way, -3, -4, -5, -6, so on. And you can also go that way, positive. Integers are a subset of rational numbers. Again, the reason why integers are a subset of rational numbers is you don't have to write what I'm about to write, okay? But I could do 2/1, which of course is 2. I could do headphones cord is getting in the way. -9/3, which is -3. Okay, so why did I start those as fractions? Well, again, that root word for rational, most of y'all said ration. Again, I see it, but you got to drop dead, and it's really ratio. Okay, root word is ratio. That's another word for fraction. So all it means is anything we can represent with a fraction. So all natural integers, natural numbers, whole numbers, integers we can. Along with, other examples like this. 1/3 is obviously already a fraction. 0.25 can be represented by 1/4. 0.18 repeating. More people would probably start as 18/99, which would really simplify to 2/11, but it's still a fraction. Again, you don't necessarily have to write those. So anything that can be represented with a fraction, you don't have to convert them to fractions though. 0.25 is what we call a terminating decimal and ends. 0.18 is a repeating decimal. All those are example of rational numbers. Irrational numbers are numbers that we cannot represent with a fraction. They have a decimal that does not repeat, It never terminates. It continues forever. Excuse me, forever. Pi is the most famous example. It's not just 3.14 and it stops. Again, that's just what y'all use to punch in the calculator and make it easier. It's 3.14159. Again, I only have it memorized to 5 places, but it goes forever. Square root of 2. Square root of 2 is an example of a rational number. But as I said in class, if y'all were in class, if not, again, you're hearing it for the first time, obviously. It's representative of any square root that's not a perfect square. So if it's not the square root of 1, the square root of 4, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. If it's a square root that's not that, it's going to be irrational. Okay? Again, pause if you're listening to me talk and didn't write, so you can pause to finish it. I'm moving on to the next slide. All right, so what I just showed is the set of all real numbers. However, there are imaginary and complex numbers as well. These will be crucial going forward in Algebra 2. So like I said, you need to learn about them this week and next week. Memorize them, know what they are, how to use them. As I said in class, I didn't have to use imaginary numbers, complex numbers in the real world until after I left Algebra 2 when I took it in high school until I got back into teaching. So I get it in that sense, but like I keep telling y'all, passing high school is the real world. To pass high school and get your diploma, you have to pass this class. To pass this class, you have to know imaginary and complex numbers. All right. We're going to use them all in Unit 1. We're going to use them some in Unit 3, a little bit here and there throughout the rest of the year as well. So this is the set of all numbers. So as y'all could see, my rectangle before was all real numbers. Now this is the set of all numbers. Real numbers has become another oval. Again, forgive this line. When I put the circle over it, it blocked it out. So I had to draw it. So now we're looking at imaginary numbers, which I use I to represent. We'll talk about I in a minute. And complex numbers is the intersection of real and imaginary numbers. A is the real part. BI represents the imaginary part. We'll look at that next week. Again, pause to copy this down. I'm moving on to the next slide. Imaginary numbers are used when trying to take the square root of a negative number. We separate out the square root of -1, which we represent with I. Imaginary numbers are used when trying to take the square root of a negative number. We separate out the square root of -1, which we represent with I. We'll talk about that more in a minute. But outside of me just actually giving you a negative square root, y'all might be saying, Coach Scharf, when am I actually going to see a negative square root and things I calculate? Again, you don't have to write what I'm about to write in white. It's just an example. Think back to Algebra 1. All right, think back to Algebra 1. Negative b plus or minus the square root of b squared minus 4ac over 2a. Good old quadratic form. Again, we're going to see it again in a couple weeks and start using it. If the b squared minus 4ac part is a negative number, I'm just going to make up like -18. Of course, you would have numbers there too, but I'm just focused on this right now. There's your negative square root, so we got to know how to deal with it. Okay. Again, as I'm erasing, you can pause to finish what you didn't get. I'm moving on to the next slide. All right, so before we start talking about this, maybe you want to ask, well, why can I not take the square root of a negative number, Coach Scharf? Well, again, it's pretty simple. We know the definition of a square root is to take a larger number and break it down into two smaller equal numbers, okay? Taking a bigger number, finding a smaller number that I can multiply by itself to get me back to the bigger number. So if I'm looking at the square root of -4, I got 3 examples, okay? I got +2 times +2, -2 times -2. Both of those are example of 2 smaller equal parts. 2 and 2 are equal, -2 and -2 are equal. But those don't multiply to -4. 2 times 2 is 4, -2 times -2, a negative times a negative is positive. So it's still +4. In the black, we got -2 times +2. Those do multiply to -4, but they are not equal parts. Again, if you look at a number line, gotta look at the camera real quick and make sure it's looking the same, y'all. Okay. -2 is going to be over here. negative 1, 0, 1, 2 is going to be over here. So on a number line, you wouldn't put it in the same spot. Okay. So how do I deal with a negative square root? When I run into one, how do I deal with it? Well, we factor out that square root of negative 1, like I mentioned a couple slides ago, which we represent with the letter I. Again, that is a letter I. It's kind of like italicized. It's got the little curve on it. That's going to confuse you if you just want to, do a straight letter I. That's fine. So we need to know that I is equal to the square root of negative 1. You'll need to memorize that. Okay. So how do I actually put it into application talking about factoring it out? Let's look at the square root of negative 4. When I factor it out, I'm going to split the square root of negative 4 to square root of 4 times the square root of negative 1. So I kind of did a factor tree because we got to get used to doing those against simplifying radicals because that's what we're going to be looking at. Again, when I do my factor tree and split this out, we got to remember what I'm saying is square root of 4 times the square root of negative 1 gives me the square root of negative 4. Y'all should have learned it at some point. When you multiply square roots together, all you do is multiply what's underneath. If you didn't learn it or you don't remember it, I'm telling you now. So that's why we could split that up like this. Okay. Square root of negative 1, like we said, automatically you got to know it's I. Okay. Again, when you're doing the factor tree, I want to see y'all do this so you have the understanding. But again, if it's got this negative sign, you got to know in your head, your answer has to have an I in it somewhere. If you have a negative sign under the square root, your answer has to have an I in it somewhere. You got to remember that. All right, square root of 4. Again, we're going to work on a factor tree on this one, but if you happen to look into this with the square root of 4, I know the square root of 4 is 2. Okay. Again, why am I saying this? Well, you might see a problem where you get the square root of negative 9. You would do the square root of 9, square root of negative 1. I know the square root of 9 is 3. So, if you understand what the perfect squares are, then hopefully you can make the connection if I got the negative sign in it. So square root of 4 is 2, square root of negative 4 would be 2i. Square root of 9 is 3, square root of negative 9 would be 3i. Hopefully y'all can make that connection. Okay. But if you can't, and you still need to split it up like this, that's okay. Again, we know the square root of 4 is 2. We remember from the vocab, the first one, the plus minus. We got to stick the plus minus on it because we just saw it a couple slides ago. Positive 2 times positive 2 is 4. Negative 2 times negative 2 is also 4. So we got plus or minus 2 times I. So I, even though it represents something, it still more or less functions like a variable. What do I mean by that? Well, if I have 2 times x, I know that's 2x. So if I got 2 times I know that's 2i, and I stick my plus or minus in front of it. All right, square root of negative 8. Start the same way. Square root of 8, square root of negative 1. I know the square root of negative 1 is I. Square root of 8, I'm going to break down. So now I'm going to do my factor tree. Okay. What can I multiply to get 8? 2 times 4. We're going to do it like this. Okay. When I'm breaking it up like this, it's still similar to what I did here and even what I did here. All right. You don't write what I'm about to put in red because all the square root signs I think get confusing. But what you got to remember is when I'm doing this, I'm still really saying the square root of 2 times the square root of 4. That's still what I'm saying, but all the square root signs start to get confusing at a certain point. So we're going to leave those off. I know this is 2 times 4. 4 goes to 2 and 2. Okay. So definitely, like I said, you don't even necessarily have to do this if you understand it. I scratch out the 4 to avoid any confusion. Even though the 8's under the square root sign, if you want to go ahead and scratch out the 8 as well, you can. We already used the square root of negative 1 turned into that. So over here, I've got 2, 2, and 2. Okay. We're doing our factor tree to get all prime factors. When I do that, I need to pair off as many of the same like factors as I can. So I've got 3 2s, so I need to pair 2 of them. Doesn't matter if I do this pair. Doesn't matter if I do this pair. I could even, skip, do that pair. All right. I'm going to do the easy one, do this pair. The single 2 that's by itself, I underline. Okay. You know, if I had 3 and 3 over here somewhere, I would circle those. If I had extra 5 kind of splitting off, I would underline that. What would all that be multiplied together? 5 times 2 is 10, 20, 40, 120, 360. So that would be factoring 360. But I digress. All right. So back to what I got. Again, you didn't have to write that. Sorry. If you did, you can erase it or scratch it out. So for every pair, I'm going to go ahead and draw my square root sign. Okay, my radical. For every pair, I'm putting one number outside. So for this pair of 2s, I put 1, 2 outside. For this single 2, I stick it back underneath. If you have a case where you have more than one number outside, more than one number inside, you would multiply them together in the end. Okay, so I've got 2 square root 2, still stick my plus minus on it. Still got the I here. So plus or minus 2 square root 2 times I. So now when I have the I in this case, I don't want to stick it. Again, don't write what I'm about to write in red. I don't just want to stick it after this. Some of y'all get a little long with your radical symbol and it might look confusing. Okay. So what you're going to do with the I is you're going to stick it in front of the square root sign, but behind any number you have out there. Okay. So 2I square root 2, and you still got the plus minus out in front. So there's your answer to that. Okay. So I'm going to let y'all practice on your own real quick. I got these last 4. All right. When you do 32, you should get plus or minus 4 square root 2. Negative 32 would be 4I square root 2. 48, 4 square root 3. Negative 48, 4I square root 3. So y'all try those on your own. You can send me and remind if you want me to check them. So there is the first day of notes. If you got any questions, send me a message on Remind. Till then, I'll see y'all in class.